Alright, so now I'd like to finish the discussion of merge sort. In class, I gave you the recursive code to kind of come up with a plan. Remember, when you think about doing recursive calls, you're kind of planning. You're not actually doing the real work yet. You're just saying, look, in merge sort, what I'm going to do, it's this divide and conquer algorithm. It's this recursive algorithm where I break things down and solve small parts first and then merge them together. I'm saying that, hey, I'm assuming that you're somehow going to sort everything between index I1 and mid here, which is halfway in between I1 and I2. And then I'm going to assume that you're going to be able to sort all the rest. And what you need to do is, after you've done that recursively, sorted the first half and then sorted the second half, you need to merge them together into one big sorted chunk. So we were starting to work on the code to do that. And the idea is, as I described in the video, so somebody came up with this code in class where they said, okay, I'm going to have a staging area Y. I'm going to have an index for that staging area. I'm going to be copying elements from each half into the staging area. And I either draw from the first half or the second half, depending on which element is smaller. So if I find, okay, I start at the first half, which is index I1. I have I be my variable that points to the first half. Then I have a variable j, which points to the beginning of the second half. And then I walk along until I've gone past the end of the first half, which is mid, or until I've gone past the end of the second half, which is I2. Okay. So as we're going along, if we find the element in the first half is less than the element in the second half, well, then we copy the element from the first half over to our staging area. And then we move to the right in the first half, okay? Because we've taken that element, now it's time to move on and see what else is left in the first half. Otherwise, we take the element from the second half and copy it to the staging area, and then we move along the second half. No matter what, we need to move along the staging area. This is an easy thing to miss. We now need to move to the next index in the staging area to accommodate the next element from these two. Okay. Now this doesn't work yet. If I run it, it actually does nothing. So let me print out the original list, and I'll print out the result here. Oh no, I guess it does do a little bit at this base case. But this code does nothing so far. And the reason is because we copied everything to the staging area, but we didn't copy it back. Okay. So we need to copy our merged sorted chunk from the staging area back into the chunk from I1 to I2. So I'll say for IDX in range I2 minus I1 plus 1. That's how many there are. So I'll say X at index I1 plus IDX is equal to Y at index IDX. So this is actually going to copy the merged sorted chunk back. We decided in class to start at index 0 in the staging area. So I have to say, well, actually index 0 in the staging area is index I1 at the beginning of my chunk. So I just have to have that offset there, and then I'm good to go. Okay, so does this do it? Let's see. Well, I was kind of better, but then what happened here? Okay, so something's wrong. Somehow I'm not getting all of the elements back. Okay, so here's the deal. Let's go back and look at an example of a merging that might happen. So let's say that here are my two chunks. I managed to recursively sort this chunk, and I managed to recursively sort the other chunk. So let's look at the code that we wrote at the beginning and try to match it up and trace through this example here. Okay, let me just get these all lined up. So if I look at this code, then I'm really saying, okay, so this is the key part here. So this here is I, and this here is J. And then this index here is mid. This is mid plus 1. and then this one is I2, and this one is actually I1. Okay. So that's the scenario we have, and we have to somehow merge this into our staging area. Okay. So we're going to keep comparing the thing at I to the thing at j, and we'll move them along. So let's see. Here, is xi less than xj? Yeah, a little bit. This one's a little bit smaller than that one. Okay, so I'm gonna copy that one down into my staging area, and I'm going to move I up. Okay. So down here is my, I'll call it I dx, but it's just moving along every time I copy a new element in there. Okay. Next is xi less than xj, no. So I copy the j in, so I go into the else there. And I copy that in, okay. Then I move I dx. Oh, I'm just copying. I'll leave them here so you can see. Okay. Just copying. I'm not actually deleting them from the original. Okay, so then I move j along. All right. Now is I less than j? Yes. Oops. So I copy that one in, move I along, move I dx along. For the next one, okay, is I xi less than xj? Yes. Okay, so now I move that one along. Move this up. Is xi less than xj? Yes. Move this along. All right, move this along. And is xi less than xj? Yes, just by a little bit. So see, look, I took a whole bunch in a row from the first one, and I didn't really move along the second one. Well, now, you know, I'm going to add one to I by this code. But now I'm past the end of the first chunk, and I didn't actually finish going through the second chunk. And it could certainly happen the other way too, if I simply flip these. So this doesn't get you all the way through all the elements, is what the problem is. So we end up copying some zeros over from the staging area because we never actually filled in everything. We just stopped here, and then everything after this was 0. So you actually need 2 more loops, one to make sure that you finish going through the first one, and one to make sure that you finish going through the second one. And if you have those loops, then this will work perfectly. Okay. So I'm going to let you finish those loops, and then we'll move on to quicksort.